Hey, this is Mr. Ward. I'm doing a short video on 3.5 types of triangles. Now, you've run into types of triangles already. And triangles can be sorted in a few different ways. You can sort them by their side lengths. So a scalene triangle is a triangle that has no two sides that are congruent. Isosceles triangle is a triangle with at least two sides that are congruent. Okay, and it'll have a base. And then there's an equilateral triangle. These are ones you're probably fairly familiar with. The equilateral triangle has all three sides that are congruent. Okay, and once these things are defined, these are all definitions here, you can start using these as elements in proofs. Now, there's one you might not have heard of called an equiangular triangle, and all equilateral triangles are also equiangular, and all it simply means is that the triangle has all its angles are congruent. So every single, which means they're all, of course, 60 degrees because there's 180 degrees in a triangle. And then there's an acute triangle in which all the angles are less than 90 degrees or acute. And there's a right triangle in which in which one angle is right, okay? And that makes it a right triangle. Once that angle is right, of course, the other two have to be acute. There are some things about the names of parts of a right triangle. These sides that are adjacent to the right angle, adjacent means next to, are called legs. And the long one is called the hypotenuse. Hypotenuse literally means stretched out. Tenuse is for stretching. Stretched out wire is what it comes down to as its origin. So in ABC, AB and BC are the legs, and AC is called the hypotenuse. And you should see if you can name the legs and hypotenuse of triangle XYZ and pause. And I'll tell you what it is. And if you thought after you paused, which I'm sure you did, that the legs were XY and XZ, but the hypotenuse was YZ, you got it right. Okay. An obtuse triangle is going to have one angle that is obtuse, in other words, more than 90 degrees. Between 90 degrees and 180, I should be specific. And of course, the other two angles, since there's 180 degrees in a triangle, the other two angles have to be acute, just like with a right triangle. The other two angles in a right triangle add up to 90 degrees, and that'll be important later. Okay. So there's a couple of sample problems in here that we should take a look at. So we've got given angle CBD, there it is, CBD is 70 degrees. Prove that triangle ABC is obtuse. And so they lay it out for you. So CBD is 70, which means, and it is supplementary to ABC, angle ABC, which would have to be 110 since it contains an obtuse angle. The triangle is obtuse. Okay, the next one's a little trickier to think through. We've got EG, and I think it'll be useful to write this out. So EG here is congruent to FH. Okay, I'm just drawing it out there to not confuse things. We also know that EF is larger than EG. So EF is greater. Let me actually write that properly. Grab my eraser. I'm messing things up here. Okay. So EF is greater than EG. Okay. Now, if EG, though, is congruent to FH, then FG has to be less than FH. And so we can now say, we're trying to prove that EFG is scaling. We just have to prove all three sides are different. So we can say now FH is greater than FG, which is one of the sides of that triangle. And then by substitution, we can take EG and FH since they're congruent. We can now say EF is greater than EG, which is greater than FG. And so therefore, if they're all a sort of string of greater than and less than and so forth, then none of the sides are congruent. So it is definitely a scalene triangle. And now we're trying to prove an isosceles triangle. So we're given angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. And we're trying to prove that KPM is isosceles. All right. Now, this is one of those ones where it might be useful to prove something about overlapping triangles. Well, let's see how we approach it. So we know that we can figure out that JKM is congruent to OMK. So JKM is congruent to OMK because 1 and 3 are congruent and 2 and 4 are congruent. If you add congruent things together, you get a congruent sum. Okay. We also know that KM is congruent to itself. So let's label things we know are congruent. So we can prove that these two angles are congruent by addition. We've also been told that JP and PO are congruent. That's this piece here and this piece here. Okay. And we know that, let's see, we know that this is congruent to itself, okay, by the reflexive property. And now we have, let's see what we've got. We've got an angle and a side and an angle. So, but let's see how they're proving it. So angle, side, angle. Okay. And angle, side, angle. So what we're using now is JKM. So we're saying JKM, triangle JKM, is congruent to triangle OMK, which was what I anticipated would likely be the thing. I'm going to label another angle because we'll need it. So angle 2 and angle 4 being congruent is important as well. And let's label this side as congruent to itself. And so now we've got angle, side, angle. So the angle here, the combination of 3 and 4, so that's OMK. And then the side here being congruent to itself. And then OKM, that makes an angle, side, angle. And then we can do JKM and the side KM. And the smaller angle, JMK, those make angle, side, angle. Okay, now we've got what we need to prove. We've got JM. We can now say JM here. JM is congruent to OK. They say KO, but I prefer OK to keep it in the same order, correspondence. And that's by Kappa. And then, therefore, JP, we already know JP and PO are congruent. And notice that that didn't get shown up, that given didn't get tossed in at first. We tossed that in later when we needed it, because we didn't need that until now. Okay, so now we can prove that KP and MP are congruent by subtraction, because those two things are the differences here. MP and KP are the differences from these larger congruent sides minus these smaller congruent sides. And if you subtract congruent things from congruent things, you get a congruent difference. Okay. And since we've now proven that, I'll go ahead and draw it in. We've now proven that KP and MP are congruent. We have two congruent sides of this triangle, KPM, which we wanted to prove was isosceles because it has at least two congruent sides. All right. Let me go down to the next page and take a look at a couple of the even-numbered proofs and maybe give you a couple hints on some of the odd ones. Okay, so let's just take a look at these odd ones. The odd ones, number one, you really just need to use the information here to determine if it is scalene, isosceles, or equilateral. And just go back and consider the definitions you've got. Okay, so we know EF here is congruent to DE, and we know DE is less than DF. Okay, so this one is different from these two, but these two are the same. This is x plus 1, and x plus 2. These are all different lengths, so you got to figure out what that means. We know AB is bigger than AC, and AC is bigger than BC. So this one's bigger than this, which is bigger than this. So they're all different. All the same sides, 2 tick marks, meaning they're the same. And these are all different size links. Okay, side links. And then, of course, it's useful to remind yourself how to determine right, acute, or obtuse. I didn't assign this one, but it's useful to remember. This one is obtuse, of course. If GH, because there is 100 degrees, we know this is right. We know that this is 60, this is 40, so that's 100 degrees. What's left is 80, and of course, this is supplementary to this one, so 100 plus 80 makes 180. So this one is acute. This one has a perpendicular part, GH and HJ. Those are perpendicular, so that means that is a right triangle. We've got 1/2 of measure K is 30, which means that measure K is 60. We've got 1/3 of measure M of angle M is 20 degrees. So 1/3 is 20, then that means that's 60. And 1/4 of measure of angle O is 15, which means, well, 4 times 15 is 60. Okay, this one is 70, 20, and then 89 degrees and 60 minutes. Well, 60 minutes is 1 degree, so that makes that 90 degrees. So that's kind of a cheap way of saying a right triangle, or perhaps an overly complicated way of saying a right triangle. Okay. All right, so a hint on this one. So use the figure mark to write a paragraph proof that ABC is acute. Well, ABC is acute. You've just got to prove that this angle is acute, and I think you can do that. On number 4, prove that COD is isosceles. And in this type of problem, you want to remind yourself this is a circle, and you were given that the radii of a circle, which are CO and DO, those are radii, are congruent. And right there, I've just identified 2 congruent sides of that triangle, so it's got to be isosceles. Here, you're going to have to come up with an equation to figure out what x is. You can already know that it's not equilateral because 10 is not 1/3 of 32. But just put them all together, add them all together, get 32, and figure out what x is. Once you know what x is, you can figure out what these 2 sides are. If HJK is equilateral, solve x and y. So that tells us that these are equal, these would be equal, and these would be equal. So that gives us, well, if these 2 are equal, we can solve for y. If these 2 are equal, we can solve for x. So x plus, I believe that is a plus. Yes, that is a plus. X plus 8 equals 15, so x is 7. And 1/3 y minus 6 is 15. Add 6 to both sides. You end up with 1/3 y equals 21. And so 1/3 of y is 21. So y would have to be 63. I believe I did that right. Now, let's take a look at some of these ones from set B. So number 7, I'm just going to give you hints. We're trying to prove that A is congruent to C. Okay. And we know AD and CD are legs of an isosceles triangle. Okay, so those are legs. B is the midpoint of AC. And so what we can do, what you're going to find useful on this one is to draw an auxiliary line. Okay, and that was something that was mentioned in the last section. Drawing an auxiliary line is going to give you, that's a midpoint. These 2 are congruent. Okay. These 2 are congruent. And this is congruent to itself. So once you've proven that, then you can take it further. Okay, given BI, so let's actually see what we're trying to prove. We're trying to prove that triangle RIB is a right triangle. Okay. We know that BI is congruent to RD, so we mark those congruent. We know that RI is congruent to BD, so that's congruent to that. Okay. And we want to prove that RIB, and we know that angle 3 is complementary to angle 2. That means that these two angles add up to 90 degrees. Okay. And we don't yet know that angle 1 and angle 2 are complementary, that they will be if this is a right triangle. Okay. So let's start proving stuff. Well, we know that this and this correspond to this and this. We could actually make this side congruent to itself, in which case, whoop, whoop, and whoop. So now we've got side, 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 and side, side, side. So those two triangles are congruent to each other. We could also do this. That's also, so these two are, so this also will be side, 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 side. So we can prove that, we will be able to prove that this and this are congruent as well. Let me back up there. I think I may have overstated some things just a little bit. All right, we definitely can prove that this side is congruent to itself. Actually, I'm going to back up and do the other one because I think that might be useful. We can prove that RB is congruent to itself. And it's going to be useful to prove that, I think it'll be useful to prove that, well, actually, there's something we can prove right now. We can prove that if 3 and 2 are complementary, then we know that there's 180 degrees in a triangle, then this is a right angle. Okay. So that's useful, I think. And then let's think about 3 and, so this angle here would then be congruent to this angle. Okay. And then we can also prove that this is congruent to itself. And then we could prove that this triangle here is congruent to this triangle here, right? Okay, which is getting messy. So I'm going to clean this up. I'm not liking the way I'm talking this through. Okay, so I'm going to start over on this one. So, and if this video is getting too long, you can stop. You can watch the rest of it a little later. And so I need to prove that RIB is a right triangle. Okay. So it would be really useful to figure out if 1 and 2 are complementary to each other. So if we could prove that 1 and 3 are congruent, then we've got it. Okay. So that's really the key here. So I'm going to prove, I know that these two sides are congruent. I know that this is congruent to this because of the givens. And I know that 2 and 3 add up to 90 degrees. Okay, so I don't need to worry about making that a right angle, even though you could prove that that's a right angle. What I really need to prove is that this angle is congruent to this angle. So what I'm going to do is I'm going to go ahead and draw, I'm going to declare that this is congruent to itself. Now, once I've done that, I now have identified angle 3 and angle 1 here as corresponding angles. And I've also created a side, 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 which allows me to prove that side, 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 and side, side, side. I can prove that RID and BDI are congruent triangles by side, side, side. Okay, and thank you for bearing with me as I work this out. Okay, so BDI and RID are both congruent, and that means that these two angles are congruent to each other. Now, 3 and 2 are complementary. Angles that are congruent to each other are also complementary to whatever. Both, this angle is complementary, so this angle is complementary because it is congruent to 3. So what that means is that angles 2 and 1 add up to 90 degrees, which makes RIB a right triangle. Okay, let me go here and let's take a look here if there's any more that I wanted to talk about from here. So hints on this one, you want to prove that EHJ is isosceles, and you know that JF and JG are congruent. You also know that F and G trisect EH, which means that all 3 of these segments are congruent. So it would probably be useful for you to be able to prove that this triangle is congruent to this triangle, because then you could use kappa kappa, and you can do that because these 2/3 of EH are going to be the same as these 2/3 of EH. That'll be congruent. And you also know that EFJ is congruent to HGJ, which means that this angle and this angle, JFH and JGE, are also congruent. So that will give you ways to prove that these triangles are congruent to each other. Let's see. Because this side will be congruent, this side is congruent, and this angle. So you have a side angle side thing. And once you've done that, you'll eventually use some kappa kappa and get where you need to be. All right. For this one, if RST is isosceles, is it also equilateral? So for it to be isosceles, 2 of the sides have to be equal. So you would figure out which 2 might be equal, and then you would see if whatever the x value was made all 3 sides. Now, it's not certain that ST is going to be the base. It could be RS, or it could be RT. The way they've drawn it, it looks like ST is probably the base. So, x plus 7 equals 3x plus 5. That would be one route to go. And once you prove that, then you can see if that makes this a reasonable value. Okay. I'll take a look if there's any more that I want to check on. Let y'all work on this one. You can ask me questions about this one here. We know AB and AC are legs, which means these 2 sides are the same. And then that tells us that this angle and this angle have to be the same. We know 1 and 3. Okay. We know 1 and 3, and these 2 would be supplementary. So that's a key to that one. And we'll stop now.